Hi guys, I'm John Hominuk and welcome to This Week in Storm Chasing. Today is Sunday, March 10th. I wanted to apologize for the lack of a video last week. I had some travel and wedding to go to and kind of all over the place, but we're back and back on our normal schedule of doing these videos every week, no matter what. Even if there's no chasing, we will discuss it. We'll discuss why. We'll talk about what's going on. And I wanted to start today by actually reviewing a chase from 2 weeks ago. So the original This Week in Storm Chasing video came out 2 weeks ago today, and that was for the week of February 25th. We highlighted two areas, one of them in Illinois into Indiana, for the potential for chasing on that Tuesday, and then another region, which I mentioned was extremely conditional for later in the week and weekend. And obviously one of those worked out, the other one didn't. I ended up chasing on Tuesday, February 27th in Illinois, and saw a tornado at night after dark, which was relatively brief, but mentioned the possibility of that in the video, and that tornado ended up being rated an EF1. So that Tuesday, February 27th, there were a bunch of tornadoes and severe weather reports. Here's the reports from the Storm Prediction Center from that day, and you can see the sort of alignment of reports up in parts of northern Illinois, and then additional reports later in the day further east out into Indiana, Ohio, even parts of northern Kentucky, and those tornadoes continued into Michigan as well. So a very active day, my first storm chase of the year, and a brief tornado rated an EF1, unfortunately damaging some structures, which was not great to see on your first storm chase, but I did get a tornado there, and that day did verify, while the later in the week stuff obviously didn't during that time frame. So let's look at this week and what do we have going on with the weather pattern as we move into the next couple of days. So the week's going to get off to a quiet start, and when we look at what's going on across the entirety of North America, the reason for that, the real driving factor in the quiet start to the week, is this trough which exists across the northeast United States. So we're looking at 500 millibar heights and wind speed, and we can see a deep storm system developing here in the eastern United States over the next couple of days. That upper level low is sliding off to the east and will, by the time we get to Monday afternoon, be moving quickly into southeastern Canada. But the northwesterly flow and jet stream continues through Monday. Now when we get ahead of that, you still have this northwesterly flow coming down through Tuesday. So what does that do, right? When we look at that at the surface, what happens is you have this surface cyclone that develops up here into parts of eastern Canada, and you get the flow around that. So you ramp up the northwesterly winds into Monday across a lot of the eastern United States, and you keep things cooler. From a moisture perspective, this storm system actually drives a cold front down through the Gulf of Mexico and really reduces the amount of moisture that exists across all of the United States. Your dew points here are down into the teens, the 20s and 30s, and even across Texas and the Southern Plains, we're in the 30s and 40s on Monday. But as we move deeper into the week, you start to see the moisture recovering a little bit. This is Tuesday morning, and you're starting to get that return flow around back out of the Gulf. This storm in the eastern United States doesn't necessarily drop so far south that it's going to drag this cold front all the way down to Mexico and totally scour out the Gulf. It kind of is a glancing blow. It moves off to the east. The front does definitely get down to the Gulf, and then as you get into Tuesday, you start to see that return flow and that moisture surging back up into the plains. Now, why is this important? Well, because after this system departs the northeast United States, the models suggest a wave will drop into the western U.S. We'll look at this in the mid-level heights in a second, but this wave dropping into the western U.S. will eventually bring southwesterly flow in the upper level jet into parts of the central plains as we get into Wednesday. Looking at the actual height anomalies, here's our storm system. This is Sunday evening into Monday. And notice I said it's a glancing blow. It's almost progressive, right? You have this deep trough and this deep storm, and it definitely has northwesterly flow component. But notice how quickly it just kind of skirts out of here. It doesn't just hang out here in the east too long, kind of skirts off to the east. Eventually, it will help develop this blocking, which is something we'll get to later. But let's watch our trough come in here. This is Tuesday and Wednesday, and the development of this amplifying ridge in the eastern Pacific allows this trough to amplify into the Four Corners and the Rockies, and that eventually is going to cut off. But the point of the matter is here that if we zoom in on the US, as we get into the midweek time frame, we're going to have a wave coming out here and moving into the central and southern plains. One of the big questions is obviously going to be, can we get this moisture to resurge back into the plains. We will have a day or so of moisture return. Starting Tuesday, we see the southerly flow coming out of the Gulf into the plains. Your dew points, obviously it's quite dry initially, but you do have about a day or so of moisture. And then this is what the European model says things will look like on Wednesday afternoon around 2 o'clock. This is just kind of borderline looking moisture, but we do have this jet coming down into the central plains. And so this would, just looking at the European model's idea here, this would tell you that there is a potential for some storm chasing in the plains this week, starting on Wednesday. Now, one of the things that we have existing with this setup is quite a bit of difference among weather models. I want to show you guys the difference between the European model and the NAM model just as an example. Let me get them aligned here. So look at the depth and the amplitude of this trough on the European, and then I'm going to flip over to the NAM. And the first thing that you notice is the NAM is just flatter with this trough. You have more westerly component to the flow here. Your trough is not as deep or as amplified. The European is more amplified compared to the NAM. And here's a GFS, which might be the least amplified of all. This is a very flat look. There's no real southwesterly component here. It's more of kind of a flat westerly look. Here's a European again for comparison. And the difference between these two models is huge because this is going to help dictate how much moisture gets back up right into the plains. You want here, in this situation, we want a more amplified trough to get that moisture return really going. And when we look at the differences here between the GFS and the European is generally going to be the more favorable solution for storm chasing. You have a deeper low, a more amplified jet, and you're bringing more moisture up into the plains. The GFS is just flatter and further east as a result. Looking at what the European does in terms of instability, right? So we know we have this set up aloft and we're getting some moisture back. Here's the idea. This is Wednesday at around 20Z, 21Z, and you can see that there's ample instability developing through parts of Texas to the Red River, and then into Oklahoma, and then up into Kansas. So overall, synoptically, we look at the European and we say, all right, this is probably something worth looking at. The GFS and NAM are a little flatter. The European is more amplified. So we do have model differences to work through, but overall, it does look like initially there will be some instability and flow on Wednesday, which gets any storm chaser's attention. Let's get into some of the details of what these different models show. So here's the European model. Again, this is valid at 0Z Thursday. So this is Wednesday night at the peak of what would be the Wednesday event. And again, we talked about the European. It's definitely the more amplified model here. Here's your jet, your 500 millibar jet core coming through, entering western Oklahoma. And you can see this is a pretty significant mid-level looking system here with that southwesterly flow. If we look even above that at 300 millibars, in the upper levels, the venting area, we still have a 300 millibar jet sort of impinging upon where we know the moisture is. It's a little removed from where we probably want it to be, but it's signaling that we have a strong mid and upper level jet stream with this system pushing into the central and southern plains. We also, as a result of that more amplified solution, have a strengthening low-level jet by 0Z. So you have a southerly or southwesterly low-level jet here pushing into parts of Texas, the Red River, and then Oklahoma, up into Kansas as well. So the low-level jet is stronger on the European because of the fact that it has a more amplified system overall. And as a result of all of that, we see this when it comes to moisture. This is valid at 21Z, so a little earlier in the afternoon, but that southerly flow coming out from the Gulf and your 60s dew points pushing up into parts of southern Oklahoma. They get up to about Oklahoma City. Here's your dry line. It's a little diffuse as modeled by the European, but you can kind of see the setup coming together, right? Here's the southwesterly flow. Here's your low-level jet into parts of Oklahoma down to the Red River, and here's your moisture pooling and pushing up northward. Now, by 0Z, this is what the instability looks like, and you can see that we have quite a bit of it in parts of Texas, and then pushing up to the Red River into parts of Oklahoma. And this is signaling the possibility of severe weather right along that dry line pushing into central Oklahoma. If we look at some forecast soundings right off that, they're fairly impressive. 72 over 60, the dew point, a little bit of shallow moisture here, but overall, this looks fairly solid. Your wind profile here, we look at this very often to try to figure out what storms might look like if they were to form. And we see the southwesterly flow, and look how these wind barbs back as we get down to the lower levels. You have southeasterly winds close to the surface, and then those southwesterly winds aloft. That's how you get that wind shear to help develop supercells and mesocyclones. So we have quite a bit of wind shear on this forecast sounding and a decent amount of Cape instability being modeled, as well as the potential for storms. The hodographs, fairly impressive as well. Likely, this profile, if you look at this just in general, would support supercells and the potential for all hazards, including hail, wind, and tornadoes. But we do have a little bit of a cap, right? And we could visualize that by looking at the temperature here, this red line. When you see that temperature go up as you go up with height, that's a cap in the atmosphere that helps to inhibit or mitigate the development of thunderstorm activity. So there's a cap here that's preventing the storms from forming. And I think it's a weak one. It's not a very strong cap that we see modeled, but it's preventing initiation. And the European does not initiate storms in this environment. That being said, this is a good looking profile for supercells. And I think when we go back and we look at this setup overall, we see this jet core pushing in here to parts of Oklahoma, Kansas, and down to the Red River in Texas. And we see this moisture pushing up as well, this instability kind of pooling here, and this profile, especially just the overall wind profile and the presence of sufficient moisture. I think we look at this as a potential chase day on the European because this is a good looking profile for supercells. Now, I mentioned that other models, specifically the NAM, are flatter, right? And here's the European. You can see that southwesterly flow pushing into the plains. And then here, again, just for comparison's sake, is the NAM. And you can see the difference. The NAM is just flatter. And that leads to not only less moisture return and a not as sharp of a dry line, but also just a little bit less impressive dynamics overall. But here's the NAM. Again, we know it tends to be a little overzealous with moisture, but still, even despite being a little bit flatter aloft, it still has those 60s dews pushing into south and southeast Oklahoma. We still have some backing of the winds, right? Mostly southerly surface wind component, but some of these near the dry line are back to southeasterly. And we still have, again, this is enough of a jet to get our attention. If we look at what the forecast sounding show on the NAM, we see a similar profile. Again, the wind profile is a little bit less impressive because we don't have that strong and favorably oriented jet. But we still have just enough southwesterlies and that backing wind here to help shear things out. So this is another supercell wind profile. There's ample instability, and we see that the hodograph looks good as well. So this is a kind of profile that could support supercells. Here's that cap again, right around 800 millibars. You see how that temperature line goes to the right there. That's your cap. That's your warmer air aloft. And that is going to prevent storm development on this model because there's no strong jet to really help, no shortwave, no jet to help get those storms going on the NAM. And then the GFS, which is an eastern outlier right now, but look how much further east it is compared to other models. It still has those 60s dews into parts of eastern Oklahoma, but that dry line mixes way out to the east, and you know your profiles are not as impressive with the jet being sort of flatter overall. But still, even on the GFS, when you look at this profile, again, it's not as impressive. Your wind fields are not great, and the cap is stronger. It's strongest on the GFS because we don't have that forcing. We don't have that jet and that shortwave coming through. But still an impressively sheared profile, and it would support supercells if we were to get anything to form in eastern Oklahoma with this profile. So just to review, the European is likely the most dynamic of the scenarios here. We see this southwesterly flow coming through. We know we have a good mid and upper level jet support for supercells. The European has the most impressive low level jet as well, and it also brings moisture and instability into parts of Texas and Oklahoma, and it results in a very impressive profile both in terms of thermodynamics and kinematics, in other words, wind shear, as well as instability. So we're looking at, on the European, a system that could be impressive and would be a notable chase day. Overall, when we look at this setup, I think we're going to draw a potential chase day here anywhere from pretty much far southern Kansas through Oklahoma and down to the Red River on Wednesday, conditional upon the orientation of this jet. I think if you get a flatter solution like the NAM or GFS, it'll likely be a less impressive chase day. You may still get convection, but if you get an event like this on the Euro, where you have a more amped mid and upper level jet and instability pushing northward into parts of Oklahoma, then I think this is a day that you really do want to be chasing, especially if the thermal profiles look like this. So that's Wednesday. What happens after Wednesday, right? That system pushes off to the east, and the models show this wave kind of amplifying up into the north and east as we head into Thursday. So it kind of flattens out, right? We talked about how unique this setup is. This wave isn't necessarily ejecting out. In fact, we have the jet stream, but if you watch this upper low here, the European says it's going to cut off and drop off to the south and east. So you have a very fast flow here still. And so this wave doesn't really have all that much room to amplify. Instead, it kind of slides off to the east and you get this broad southwesterly flow through the upper Midwest and parts of the Mississippi and the Ohio Valley. As a result of that, your instability profile is kind of interesting. So we know we have this moisture advection, and this is Thursday afternoon, and it looks sort of like a cold front, right? It's sort of a southwest to northeast orientation here, Thursday afternoon to evening. You don't get a ton of instability up here in the plains, but still just enough maybe in the upper Midwest. Again, looking at the jet stream, here's your low-level jet. So there is an impressive southwesterly flow, and your mid-level jet stream is southwesterly as well. So initial impressions don't look that exciting for me from a storm chasing perspective here on Thursday, especially given the potential terrain that we're going to be operating in. But you do have strong jet stream orientations and strong jet stream winds, as well as a decent amount of instability and moisture moving into the eastern plains and then the Midwest and parts of the Mississippi Valley. So let's click around a little bit. And I'm going to start by looking at the European model here just at the Ed18Z. So your low pressure system is already into parts of southern Iowa, and this is already looking fairly progressive to me. But you have a warm front extending out this way, right? This is over parts of Illinois and Indiana, so you have some ongoing convection. And then you have the front draped down here through parts of the eastern plains, Missouri, and then into parts of Arkansas. If we look at our moisture, here are our dew points. You can very clearly see where the warm frontal orientation is, but notice how the vast majority of these winds are running parallel to the frontal boundary. We know we have the front draped this way. All our wind barbs are pointed southwestward here. We don't have a ton of backing of those winds. But let's just, for the sake of it, we'll look at what we have from an instability perspective, and let's click into the warm sector and see what the models are showing. So here's the instability axis, and let's just look at an area average within that instability axis. And here's what we see is a very boring profile. We have moisture, we have some instability, but we have very little wind shear to speak of here, mostly southwesterlies, and a sort of a straight hodograph, and really not that much going on in terms of interesting chasing. That's on the northern part of this warm sector. If we go a little further south and look at what's happening in parts of Arkansas, which to me is mostly no chase territory, we also see a fairly straight wind profile with some backing in the very low levels that enhances some wind shear locally. But there's still not a whole lot to write home about here from a chasing perspective with this profile in general. If we fast forward this to 21Z, there's a lot going on here. We have some convection ongoing here, likely not supercellular, at least the way that it looks to me right now, but kind of a little bit of a mess overall. Convection going all over the place here. So the European not doing a great job here, not going to offer us much in terms of help. But look at the moisture here, even in parts of Arkansas that's still developing amidst this convection. And if we take some area average soundings, again, there's really just not a whole ton going on here. Lapse rates are decent, winds are sort of straight, and you have a little bit of low-level backing. But there's really not a whole ton of wind shear. Clicking up on the warm front, which we see in Illinois, again, just trying to figure out where some threats might be here. There's really just still not much going on. The shear is kind of weak overall in terms of supercells. And the hodographs look to support some severe weather. But overall, when we look at this setup and kind of poke around and look at it, the low-level jet is really not that impressive. You have your mid-level winds pushing through, your southwesterlies. We looked at this on a national scale just a couple minutes ago, and we have moisture. And so we have the instability to produce a severe weather event here. There's likely going to be severe weather, but there's just not a whole ton of support for storm chasing here. If we go back to the national view and look at what's going on here, we can see the depth of this moisture is impressive moving into parts of the southern plains. So if you want to click around and look at that and see how that looks, here we see some more moisture and instability. I'm going to scroll down and pull up the surface cape and see what the models suggest might be the case here for instability in parts of the south. Look at Louisiana, where we could have some possible severe weather. This profile is a little bit more impressive. You see some more curvature to the hodograph in the low levels here, and some more curvature to this wind profile overall. Also more instability and more cape. So, more instability and moisture. So we could see a severe weather threat here, but this is sort of very difficult chasing territory, as all of you know. In eastern Texas and Louisiana, you're really putting yourself in a tough place to storm chase. This is a little earlier, and again, I'm just poking around here just to give us all a view on what might be happening. And again, there's more curvature to these profiles down here. The hodograph's a little more impressive, and the wind profiles with a little more curvature. But to me, Thursday, in general, if you're going to be chasing, it's going to be down here in worse terrain. There's moisture, there's instability, there will be storms. I just don't know how functionally this turns into a really strong or impressive storm chase. From a storm chasing perspective, I'm going back and I'm looking at this event on Wednesday. I'm looking at this jet stream. I want to see this instability axis. And this is the day that I'm looking at, which is, again, this is Wednesday when this southwesterly flow comes into the plains. This is the day that I'm looking at for the possibility of some storm chasing. So we'll highlight areas for Wednesday and Thursday, but Wednesday is going to be the one that I think offers the better chance for storm chasing. So we know we have Wednesday. We know we have Thursday. What goes on beyond that? Is there more storm chasing to happen in late March? I asked a couple of guys on Twitter. I said, if you guys have any questions, let me know. And we did get a couple of questions. One of them came from my buddy Taylor, and he said, is there going to be, is this going to continue into late March or early April? I'm paraphrasing. I don't have it in front of me right now. But the question was, is this going to continue? Is the Gulf going to stay open? And are we going to chase into late March and early April? The unfortunate reality, I think, is that the answer is no. So let's pull up the European ensemble, and we can walk through the reasons why. I'm going to back us up to the northern hemisphere here, and I want to show you guys something that's happening to this weather pattern that I think is going to be detrimental to storm chasing, and it's the development of high latitude blocking. So here's the pattern over the next couple of days. We see our trough dropping in here to the southwest, and we have the storm chasing potential that comes out of it as a result. But the ridging that builds up here into western North America and the higher latitudes, that just continues to expand up into British Columbia and up eventually into parts of Alaska. So what that does, the domino effect, is that it digs a trough into the eastern United States and eventually allows high latitude ridging to expand further. So you have ridging all the way up into the EPO regions of Alaska, and that flow through the Arctic comes down straight into the United States. This is a colder pattern regime and one that is dominated by high latitude blocking. So zooming into North America and looking what the European says will happen from a temperature perspective, there's that flow, right? It's straight through down from the Arctic into the United States. So spring is very likely going to be put on hold in March. I don't think we're going to totally scour the Gulf out with some crazy Arctic outbreak, but I do think that by the end of this week, we're going to shut things down from a storm chasing perspective for probably 10 to 14 days at bare minimum, taking us through middle and latter part of March. Looking at the European weeklies just for some added confidence in this, and they agree that this cold is coming. It's likely going to be oriented northwest to southeast as that blocking continues into late March and maybe even lingering into that first week of April as that high latitude blocking continues. So we have the chases Wednesday and Thursday. We're going to turn it off for a little bit here in late March. But you know what? That's all part of the long-range forecasting process that we've talked about. When you go back to the tornado forecast video I put out a couple weeks ago, all of our analogs had this blocking during the second half of March into April, and all of them brought chasing back in mid to late April and then into May. And one of the main reasons is this, and that is the development of the La Nina, which over the last couple of days we have seen the colder waters upwelling and emerging in the eastern Pacific and shifting out into the central equatorial Pacific. The model's in good agreement as we move forward that this La Nina will continue to develop. And that puts us firmly in a type of season called a terminating El Nino transition year. So we're killing off the El Nino that's been in place, and we're transitioning into a La Nina as we head into this chasing season. And that is a huge critical factor for a lot of the analog years that we've been building. So taking a look at those analogs, I'll start with March. These are what our analog years showed for March. And honestly, they're doing a pretty good job. They have the blocking developing second half of the month. You could see that block forming here. They have the active flow and troughing that's underneath. We've already seen this so far this month, and we're going to see additional troughing like this as we move through the month. So that was the analog set for March. So far, doing pretty well. And here's what happens when you roll those analogs forward into April, May, and June. And the first thing you're going to notice is this big trough in the western United States, right? I mean, this is kind of the harbinger of good things to come when it comes to chasing. This is, and I discussed this in our seasonal video, which you can go back and watch, but this April, May to June look is active with southwesterly flow coming out into the plains. You also have this high pressure sort of sitting here in the eastern U.S. in between these troughs, and that has the return flow coming around. And so all the ideas here on this chart point to the likelihood of an active chasing season. That's why I've been so gung-ho on the potential for this active chasing season, especially with the transition between El Nino and La Nina. So while we might be killing things off in late March or into early April, I think that by mid and late April and then into May, we're going to be right back in action. Do the models agree? Here's what we got from the European seasonal just a couple of days ago, and boy, does it agree with that idea, right? You can see almost exactly where the troughing would be here in the western U.S., and we see an active precipitation pattern. You can almost envision your dry line here in the Central Plains, above normal precipitation across eastern parts of Nebraska, Kansas, Oklahoma, and then active in the Midwest. And then when we fast forward that to May, even better. I mean, this is a classic look here. I don't like to get too much into the models, but when we use them as supplementary guidance to our analogs and our atmospheric, our meteorological thought process, they can be really helpful. And this adds confidence because it's telling us what we're seeing right now, what we're putting together with the analogs, it makes sense. It actually makes sense. So here's your seasonal anomaly. This is April, May, and June, and you can see very clearly the signal for above normal precipitation and an active chasing season, specifically from April into May across a lot of the Central Plains. So we're going to chase here probably during the middle of the week. As we get closer, we'll get better ideas. Specifically, Wednesday to me looks interesting. No guarantees, but looks interesting. I'd keep a close eye on that. Then we're going to shut it down for a little bit in late March and early April. And as we get forward into mid to late April and May, I think we're going to really kick this off and be full-fledged into chasing season. And it's looking like a good one from this standpoint. I'll be back with videos throughout the week breaking down Wednesday's event, and then, of course, with another This Week in Chasing video next Sunday. Thank you guys so much for watching and supporting the channel. I'll talk to you soon.